Hey physics kids, this is mechanics number 13 now. This is the second one we're doing on wedges. This is where we introduce the frictional force to wedges, and we really put it together. This is becoming very, very real world. We're able to now do things on angles. We're able to introduce friction. Check this out. So we're going to set it up and start with the same wedge problem we did in mechanics number 12, but now we're going to introduce friction on it. So we'll have all the same stuff. All right, so we have a wedge. I'm going to draw it this way. There is no reason that the wedge has to be one way or the other. And I try to flip them back and forth. In some years, I've always drawn them one way, and people, and when I flip them around, they're like, "Oh, how do you do that?" So get used to drawing them either way. It shouldn't be a problem. So we have a 3-kilogram box here. We have an angle of 36 degrees. But now we are going to introduce a mu. In other words, a frictional coefficient between the box and the inclined plane. In this case, we're going to say mu equals 0.19. 0.19 for mu. Okay, so I think we could get started. What's the first thing we do? Well, we turn the box into a weight. All right? So we have F equals ma, which translates to W equals mg. Remember, that's how we find weight. So we take our 3 kilograms times 9.8 meters per second squared. We get a weight. Now notice I'm going to put it over here because the triangle is going to get drawn here. So 29.4 newtons. Okay, that's the weight. That's the progenitor of all the other forces. So that's the big one. Well, then we're going to have another force perpendicular to the plane. Do you remember what we call that force? Force perpendicular. Then we have another force parallel to that plane. Force parallel. Okay. Now, take a look at your drawing. You really need to stop and take a look at your drawing. If your drawing is wrong, this is going to go bad. So, is your drawing good? Is the weight going straight exactly down? Is your perpendicular force actually perpendicular to the plane? So far, so good. Parallel? Parallel looks parallel. We're doing great here. All right? So I take this angle. I now know that that angle goes in here, 36 degrees, and now I can start solving stuff. So why don't we solve now for both perpendicular and parallel? But here's a hint. Do parallel first. All right? So do parallel. 29.4 times 36. And is that sine or cosine? Well, it's the opposite side. That's sine equals 17.2 newtons. 17.2 newtons. Now, I want to keep track of things, so I'm going to do it right here. This box is being affected by a force applied of 17.2 newtons. It is not the only force because we have friction, so we got to find out the frictional force. Well, if you remember, the force of friction is equal to F sub F equals mu, which is that, times F sub n, the normal force. Now, is the normal force the straight up force? It is when it's horizontal, but that's not how I defined the normal force. The normal force is the perpendicular force, and it's straight up because most of the time, so far, we've been doing horizontal problems. So normal would be straight up. In this case, though, normal is exactly opposite and equal to the perpendicular force. So this is your force normal. So once you know your perpendicular force, you also know your force normal. It's not the same thing. Please know that. Perpendicular force is pressing down, normal force is pressing out. If you're standing on a roof, the roof is pushing out the component that you're pushing down, and that's not your full weight, right? Some of your weight is actually parallel force trying to pull you off that roof. So it's the perpendicular force that allows you a little bit of friction on that roof. Anyway, what is that force perpendicular? 29.4 newtons times, well, what's this going to be? That's the adjacent side, so that's 36 cosine equals 23.8 newtons. 23.8 newtons. Okay, finding force of friction then, you can see is pretty easy. 0.19 times 23.8 newtons. That is because that's my normal force. Perpendicular, but equal to the normal force. So 23.8 newtons on the normal force. Well, what does that all equal? Times 0.19. That equals 4.5 newtons. Which means, if this is my force applied, pulling this down, I now have a small force, not insignificant though, force of friction equals 4.5 newtons. Getting there. So now I could say my net force. What's the net force here? Well, my net force equals force applied minus force of friction. Well, that makes sense, right? Here's my force applied, there's my force of friction. So I'll put a negative on that, and I'll add 17.2, and I come up with a net force equaling 12.7 newtons. That's a net force acting on that 3 kilogram object. Net force acting on a 3 kilogram object. So we go back to the formula, F equals ma equals, so this is a net force, F net equals mass times acceleration. I'm looking for acceleration. If I divide both sides by mass, I think I got it. A equals F net over m, or F net of 12.7 newtons divided by 3 kilograms. Do the units work? Well, a newton is a kilogram meter per second squared. They cancel. I'm going to be left with units of acceleration. I'm just as excited as could be. So if I divide that 12.7, which happens to be on my calculator, divided by 3, that equals 4.2 meters per second squared. And is that my answer? That, ladies and gentlemen, is my answer. That's how you do that. They're work at first, but after a while, man, this is using all the physics you've learned so far in this first 2 months. It really is using all of it. And I hope you find it a little bit of fun. When you find stuff like this fun, you win, because you'll do them just for fun. Imagine taking a test on something you regularly do, kind of for fun. People play Sudoku puzzles, which have no meaning in this world whatsoever. They do that for fun. I hope you get yourself to see this as kind of an enjoyable thing to do. It's pretty cool. One thing leads to another, and you do the physics dance throughout this. So, do some practice problems of this. I'll put some more up, but work at it. You want to know wedge problems. You will see lots and lots on wedge problems. This is the entry into a whole lot of physics. So, thanks for watching. See you next time.